at all. Pretty much everything you need for that first quick safety check, it's all right here. Think of it like this. It's the vessel's birth certificate and its driver's license all rolled into one. You know, I watch rookies walk past these things every single day. And to them, it's just a jumble of letters and numbers. But you're going to see the whole story. You're going to see the safety case right there in front of you. And let me be clear, this isn't some textbook theory. Learning to read this plate is the very first thing you do on any inspection, any audit, anytime you're troubleshooting, no exceptions. Okay, so here's our plan of attack. First, we're going to treat this plate with the respect it deserves. It's a critical safety document. Then, we'll break down the must-know fields one by one. After that, the important part, connecting those numbers to actual, real-world risk. I'll also show you the big red flags, the things that should make you stop dead in your tracks. And we'll wrap it all up with a dead simple checklist you can and should use every single time. Look, every single line on this nameplate is there for a reason. It's not just random data. Each line is an answer to a critical safety question. Your job is to know what questions to ask. All right, let's start with the big one. The absolute first thing your eyes should jump to is MAWP, maximum allowable working pressure. This number, this is the whole game. It's the absolute pressure limit for this vessel.
But here's a detail you absolutely cannot miss. That MAOPW is the limit when it was new. You got that? This is a pressure rating for day one, right out of the fabrication shop. It's our starting point, our baseline. But it is not necessarily the safe limit for today, and trust me, we're going to circle back to that.
Okay, so right next to the pressure rating, you're always going to find temperature. These two are a package deal. You can't understand one without the other. Seriously, they're joined at the hip. So what does that really mean? It means that MAWP we just talked about, that 150 psi or whatever, it's only good at that specific design temperature. If you run this thing hotter, the metal gets weaker. Guess what happens to your pressure limit? It goes down. And if you run it too cold, you could get brittle fracture, which is just as bad. These two numbers create the safe box you have to operate inside, the safe operating envelope. Now we get to the legal stuff, the design code and the stamp. This right here, this is the heart of the nameplate. It tells you the rule book this vessel was built to play by. So when you see that ASME stamp, or maybe a CE mark for the PED, that's your proof. It's proof it was built to a very strict, legally binding standard. It tells you everything, the quality of the welds, the type of steel, the tests it went through. Without that stamp, what you're looking at isn't a certified pressure vessel. It's just a big metal can, and that's a huge problem.
Okay, so now you know what the lines mean. That's the easy part. Now comes the real skill, connecting the dots. How do you turn this data into a quick risk assessment, right here, right now? This, my friend, is what separates someone who just checks boxes from a real inspector.
So the very first question that should pop into your head is this one. And listen carefully to the wording. What is the maximum safe pressure today? Not when it was built, today.
And here's why that word today is so critical. See, the plate might say 150 psi, great, but it was also built with something called a corrosion allowance. That's a little bit of extra metal thickness that's designed to be eaten away over the years. So, has some of that metal gone away? You bet it has. That means the real, true safe limit today is definitely less than 150. You might not know the exact number standing here, but you know for sure you can't just run it up to the number stamped on the plate.
All right, next question, and this is a big one, a real showstopper. Is this vessel even legal to be running right now?
It's simple. You find the year built on the plate. Let's say it's 2016. Okay, now you know the code this thing was built to usually requires a big inspection every 10 years. You check your phone. It's 2026. Boom, just like that, in under 10 seconds, you spotted a huge potential compliance problem. That thing is probably overdue for inspection, and that needs to be checked out, like right now.
Okay, now let's talk about the easy stuff, the low-hanging fruit. These are the big, bright red flags that should set off alarm bells in your head the moment you lay eyes on them. And this one's probably the most common thing you're going to run into. Some crew got a little carried away with the paint, and just like that, your single most important safety document is completely unreadable, useless.
So what do you do? This isn't a trick question. It's not a suggestion. There is only one correct, non-negotiable procedure to follow here.
It's a simple three-step process. Step 1, stop doing. Whatever you were about to do, you stop. You can't rely on data you can't read. Step 2, find the paperwork. Go hunt down the manufacturer's data report, the U1A form, whatever drawings you can find. Step 3, escalate. Go tell your supervisor that the data in the field is compromised. Because let me tell you, assuming what that plate says is the fastest way to get somebody seriously hurt.
Okay, this next one is even worse. You can read all the numbers just fine, but that all-important U stamp or CE mark, it's gone. This isn't just a data problem anymore. This calls the entire legality and safety of the vessel into question.
The procedure here is pretty similar, but the urgency is cranked up to 11. You stop all work immediately. This is way beyond a missing number. You could be looking at an illegal, uncertified vessel. Your next moves are to verify its history through documentation and escalate this as a high-priority safety and compliance emergency.
All right, let's wrap this up. We're going to take everything we just talked about and turn it into a mental habit, a simple checklist that you run through automatically every single time you walk up to a piece of gear.
I want you to burn these 5 questions into your brain. What's the code? What's the max pressure? What's the max temperature? What year was it built? And then, the killer question, the one that really matters, what has changed since that year? Has it corroded? Been repaired? Has the service changed? Answering those 5 questions gives you a powerful snapshot of the risk, and it takes, 30 seconds?
And I'm going to leave you with one final piece of advice. And you need to remember this. If the metal in front of you and the paperwork in the office tell you 2 different stories, the paperwork wins. Every single time, at least until an engineer re-rates it properly. Your job is to trust that documentation and flag the problem. The nameplate gets you started, but the paperwork is the ultimate authority. Don't you ever forget that.